Chapter 1, Part 1. So the first thing we're going to do is review absolute value. Remember that absolute value represents the numerical distance a number is from 0 on a number line without regard to its sign. The symbol for absolute value are these two vertical bars. So when we see something surrounded by those vertical bars, we know that they're asking us to find the absolute value. Since absolute value is always positive, because distance is always positive. So absolute value will never give us a negative answer. For example, the absolute value of -3, well, it's 3 units from 0 on the number line, so the absolute value of -3 is 3. The absolute value of 5 is 5, because 5 is 5 units from 0. We don't care if it's to the left or to the right of 0, just how many tick marks until we get back to 0 is what absolute value determines. So a couple of quick examples. 1a says the absolute value of 54. Well, that's just 54, because it would be 54 units away from 0. Letter B says the opposite, or negative, of the absolute value of -7 3/3. Well, the absolute value of -7 3/3 would be 7 3/5 would be 7 3/5, and then we have to make it negative because that negative on the outside. So that's the only way you're going to get a negative out of absolute value, is if they have something on the outside, some operation that turns it negative. The actual absolute value itself comes out positive. Okay, so we can do some operations with absolute value. Here we need to find the absolute values first, then do the subtraction. So the absolute value of 3 is 3. And we're supposed to subtract from that the absolute value of -1. Well, the absolute value of -1 is 1. 3 take away 1 gives us a final answer of 2. Letter D, we have the operation inside the absolute value, so we have to do that operation first. So if you take 5.13 and subtract the 2.2 from it, line up your place values. To borrow, you can do this on a calculator if need be. You're going to get 2.93, but it would have been negative because we were doing the smaller minus the larger. So you'll get -2.93 inside the absolute value bars, and then you take the absolute value of that to get your final answer of 2.93. Okay, so now you're going to open the Math IXL app. So you're going to select Algebra, then go to Numbers. A.3 is the section we're focused on. It's absolute value and opposites, so it's in that very first section. You're going to complete 10 problems or reach a SMART score of at least 68, whichever comes first. Then you're going to return here to finish this video and notes. Keep in mind, absolute value comes out positive, and when they talk about opposites, opposites are where you just flip the sign. So if they ask for the opposite of 12, you would say -12. If they ask you for the opposite of -3, you would say +3. You do the opposite sign. Whereas with absolute value, if they give you the absolute value of -12, that's going to equal 12, as would the absolute value of +12. So they would have the same absolute value, or the absolute value -3 would be 3, or the absolute value of +3 would also be 3. So absolute value always comes out positive. When they talk about opposites, you're just flipping the sign. Okay, so our next topic in Chapter 1 are function machines. A function works like a machine as shown in the diagram below. A function is given a name that can be a letter, such as f or g. The notation f of x represents the output when x is processed by the machine. Please note that it's read f of x. It does not mean f times the x value. I know that often in math parentheses mean to multiply when things are shoved together, but this is a special notation called function notation. The beginning letter is the name of the function so that we can distinguish between different ones, and then inside the parentheses is your input. So we say f of x. When x is put into the machine, f of x, the value of the function for a specific x value, comes out. In this notation, f of x replaces y. So when you see f of x, this entire expression is the same thing as y. It's the output. Numbers are put into the function machine. In this case, our function machine is f of x equals x squared minus 1, one at a time, and then the function performs the operations on each input to determine each output. For example, when x equals 3 is put into the function f of x equals x squared minus 1, the function squares it and then subtracts 1 to get the output. So if we square 3, so f of 3 means we have to square 3, take away 1. This left-hand side is all notation. It's just telling us we're using the function machine named f. We're evaluating it for 3. You don't do anything here on the left-hand side. It just stays there the whole time. It's naming the function and telling us what we used as an input. We only do our math on the right side. So 3 squared, remember, means 3 times 3, which is 9. Then we take away the 1, and we get 8. So f of 3 equals 8. And that's your answer. The notation f of 3 equals 8 shows that the function named f connects the input of 3 with the output of 8. So in letter A, they ask us to find the output for f of x equals x squared minus 1 when the input is 4. That is, we're supposed to find f of 4. So f of 4 equals 4 squared, which means 4 times 4, or 16. Take away 1. So then f of 4 equals 15. So that's your answer. When the x value is 4, the function gives us an answer of 15. So now we're going to find f of negative 1. So we're going to replace x with negative 1 and simplify the right-hand side. This left-hand side is notation, it stays there. Negative 1 squared means to do negative 1 times negative 1. If you choose to use a calculator, you have to type it just the way I've written it. You have to type parenthesis, negative 1, close parenthesis, squared, take away 1. If you do not put the negative 1 in parentheses prior to squaring it, it will tell you it's negative 1. But we know that when we square values, it always comes out positive. The negative times the negative cancels and gives you positive 1, take away 1, so that f of negative 1 equals 0. Now I'll do f of 10. So this means to take the function and replace x with 10. So we'll do 10 squared, take away 1. So f of 10 equals, well, 10 squared, 10 times 10 is 100, take away 1. So f of 10 equals 99. Part C says if the output of this function is 24, what was the input? That is, if f of x equals 24, then what is x? So we're going to replace this f of x, this entire expression here, with the value 24 and work backward to find our x value. So 24 equals x squared minus 1. And I need to figure out x, so I want to get it by itself, so I use inverse operations. The opposite of subtracting 1 is to add 1. So then I see that 25 equals x squared, and I have to think to myself, okay, what's the opposite of squaring? How do I undo the squaring? And that is with square root. Square root is the opposite of squaring. So the square root of 25 is 5. The square root of x squared is x. So we see that x could equal 5, but they ask us an important question here. Is there more than one possible input? Well, let's think carefully about squaring. What other number could we square to get positive 25? The answer would be negative 5. Both 5 and negative 5, when squared, when multiplied by themselves, would give us positive 25. So function machines are just another way of talking about rules or equations. Remember that this is notation. They name the function, they tell you the input. You don't do anything here. It's the same as y equals. All your math is done on the right side. You'll plug in your x values and simplify this right-hand side when they give you the input. Or they could switch it up and give you the output, in which case you put that value, whatever the output is, in place of the entire f of x, and you work your way backward to solve for x. You should have all of your Part 1 notes filled in at this point, and you should now continue on to do the Chapter 1, Part 1 assignment.